Hello, CS111 students. My name is Peter Mahorter. I'm one of the lab instructors for the class, and this video is going to be a walkthrough of the instructions for the turtle scene task. These videos are completely optional. I'm just going to be reading through the instructions of the task. For some people, that helps to sort of organize their thoughts and make sure that they see everything. But for other people, you can just read the instructions yourself. Below this video, there should be a link to the actual instructions that you can read instead of watching this video if you prefer. So we're going to talk about the turtle scene task, and it's part of problem set 1. There's a file scene.py. It does not exist yet. You are going to create this file, and that's where you're going to put the work for this task. So for this task, we want you to get some practice writing code at the most basic level. And also become familiar with the drawing libraries that we'll use called Turtle and Turtle Beads. And this is a very open-ended task. There's no restrictions on what you draw. The only requirements are that you use certain features of programming in order to do your drawing. And so you'll create that scene.py file from scratch, create it in the problem set 1 folder, and make sure that you have the turtlebeads.py file in that folder so that you can access that library. Turtle is a library that's built into Python, but turtlebeads is not. It's one that we're supplying. Now, in the following text, which I will be going through, there are some blue links with a C next to them and yellow links with an E. And those are going to show you the goals from the rubric. And I'll talk about the rubric at the end a little bit, but we should just pay attention when those links come up. There's actually one of them on the screen right here. Near the bottom, it says, C, import the TurtleBeads module. So that's one of the defined goals for the task. And the purpose of these instructions is to explain what you have to do, but the rubric is actually what defines how you'll be graded. So the file that you create, scene.py, should start with a triple quoted string at the top. That means 3 quotation marks. They can be either single quotes or double quotes, but they have to be one or the other. And then some text, and then 3 more single or double quotes. In Python, we call that a triple quoted string, and you can put extra information in there. It won't become part of your program. It's not interpreted as code, it's just text. When we put a triple quoted string at the top of the file, that has a special meaning. That is the sort of documentation for the file. We call that a doc string. And so in this file, you should start with a triple quoted piece of text that says authors, consulted, date, purpose. And for each of those, it lists a value. So you should put your own name as the author's line. And if you're working with a partner, then both of your names go there. If you get help from a tutor or from an instructor or from another student in the class, then you should put their name under the consulted line, and maybe that will be empty or maybe not. Under the date, you should put the date that you started the file, and theoretically at the end you should put the date that you finished the file and update that date as you go, but you don't always do that. But some relevant date so that it's approximately when you authored the file, and then for the purpose, it just is the turtle scene task. In general, when you're creating your own files, you should have some kind of notion of what the purpose of the file is. For most of the problem sets, we'll say, hey, this is the purpose of this file. Not terribly important, but good to have some text there. So after you put this text into your file that you just created, there's some requirements, and you're going to have to refer back to the lectures and labs in terms of how to satisfy these requirements and how to use these things. But the requirements are, first, you have to import the TurtleBeads module. And this is kind of a silly thing to be a requirement, because to satisfy any of the other requirements, you're going to have to do this anyway. But it is required that you import the TurtleBeads module, and reference the lab for how to do that if you have forgotten. Notice that these little goal snippets here, if we click this, it'll pop up this rubric tab. And if I click this again, it'll go back to the bottom. You can see rubric and examples at the bottom of the screen right now. If I click on rubric, it'll pop back up. And in that tab, it'll jump down to one of these goals. So the rubric tab has a lot of different stuff in it, and it's basically listing the goals. We'll get back to that later, but it's nice to know that you can click these links to show you in the rubric what is that specific goal and how is it defined. Okay, so requirement number 3. You have to use some basic functions from the built-in Turtle. stuff. And there's a reference link here that you can click to get our reference pages, which give you examples of how to use those functions. You can also refer back to, you probably use those functions in lab, for example. So the forward function, the backward function, the left function, the right function. You got to use each of those. Then you have to use an absolute positioning command. So these functions basically move the turtle relative to where it was before you call the function. The absolute position commands go to a specific point on the screen, regardless of where the turtle was before. These are set x, set y, set position, which has different spellings, or go to. There's also a teleport command from TurtleBeads, which is like these other movement commands, except it also doesn't draw a line as it moves. You can use any of those to satisfy this requirement. And again, if I click on this, it'll bring up the rubric, and it says explicitly you have to call one of these things in at least one place. Okay. Requirement 5, you have to use each of these TurtleBeads shapes. And again, there's a reference link here where you can read more about what they are and how to use them. But you have to use draw circle, draw rectangle, and draw text. And it does mention that if you want, you could use the circle function instead of draw circle, or the right function instead of draw text. But draw text and draw circle generally are a little bit easier to use. These, notice these are yellow and have an E next to them. These are what we call extra goals. So the blue are core goals, and if you complete all the core goals, you've basically completed the problem set, and you'll get a 95 out of 100. The extra goals are only worth that last 5%. So you pursue these extra goals after you have done all the core goals. It's a good strategy for tackling the problem sets. Okay, I won't get too much into the grading here. There is a reference on the CS111 website about exactly how the grades break down. That's our problem set and quiz reference that you can find through the nav bar on the left. Okay, so other requirements for this problem set. You have to vary the thickness and color of lines using pen size and either pen color or color. Again, there's some reference links there. You have to use begin fill and end fill to draw a filled-in shape, and use fill color or color to control the color of that shape. Now notice that, for example, you could use color to satisfy parts of both of these goals at once, and that's valid. You can use one function to satisfy multiple goals if that's the way the goals are set up. You have to use pen up and pen down to move the turtle without drawing a line, or use one or more of the teleport, leap, or hop functions from TurtleBeads that do the same thing. And my opinion is it's easier to use these other functions, but you could also use pen up and pen down if you wish. Again, these are extra goals, not core goals. And finally, you have to use title to assign a title to the window. Okay, you're welcome to use other functions than the ones we have listed here, but you have to use those functions to score full credit for the problem set. If you want to challenge yourself a bit and read ahead, we will talk next week about defining custom functions. You could, if you wanted to, define a custom function and use it as part of your turtle scene, but there's no credit associated with that. It's not even an extra goal. There's a note down here. So as you build your scene, especially if you are building a very fancy scene that looks really cool, you'll start drawing a lot of stuff. And every time you make one little change, it'll take a long time for the turtle to draw everything to get to where that change is occurring. In the TurtleBeads module, we provided functions called notrace and showPicture, which you can use together to make the drawing nearly instantaneous. The trick is that if you use notrace, you must use showPicture too. So if you use notrace, you can call it at the very beginning of your file, and all the drawing from that point on will be basically instantaneous. But if you don't call showPicture at the end, some elements may just randomly decide not to show up. So if you use notrace at the beginning, use showPicture at the end. And there's another documentation link with explanations of those functions and examples of how to use them. Okay, now normally for a task, you would just submit the file on the Potluck server. But for this task in particular, we want you to also take a screenshot of the beautiful image that you have created. And there's submission instructions. You can click that link to read them. They're for the whole problem set, but they have the details about this screenshot. So take a screenshot, give it a particular name based on your username or your usernames if you're working with a partner, and then upload it to our Google Drive folder. So in general, the problem set descriptions, in addition to the instructions that we just finished reading through, will include a section of examples. And this is pieces of code that show you how things are supposed to work or give you an example to remind you. So there's two examples for this problem set. This first example is just a reminder of how to use the most basic functions like forward, left, right. Notice that there's abbreviations like FD for forward that you can use to save yourself a little bit of typing. And this example shows that, well, if you took this code and you run it, this is what would be printed out. And then here's the image that would pop up. And so this code just draws a triangle by moving forward, turning left, moving forward, turning left, moving forward, turning left to face back where it started. There's another example here of how to fill a shape. If you need an extra reminder of that. So it talks about the begin fill and end fill functions. Again, here's the code. So we call begin fill, then we draw our shape, then we call end fill. Here's what is printed, and here is what that looks like. Notice that if I scroll up the page, the examples appears down here at the bottom as a little tab. If I click that, it'll expand, and I can scroll through the examples while I'm also looking at the instructions if I want to sort of cross-reference things. And the same is true of the rubric. I can cross-reference something from the rubric, and remember these are links, so I can click one here to scroll to the right place in the rubric. But I can also just scroll down past, let me just expand this. If I scroll down past the examples, eventually as I scroll, I will also just get to the rubric. And the way that we recommend you use the rubric is as a sort of checklist at the end when you're done, but also maybe as a guide in the beginning. So we recommend that at the beginning, as you're starting a problem set, you read through the rubric to understand exactly what's required. The instructions try to spell things out at the big picture, but the rubric is what defines how you will be graded. In particular, there may be things in the instructions that say, oh, you have to do this, this, this. But it turns out that those things are extra goals, not core goals, and so maybe they're not the thing you should focus on first. So read through the rubric at the beginning to have an idea of what you're doing, and then at the end, try to go through the rubric and check off mentally or using a separate file each item to say, hey, have I actually done this? Does my code do this? And so the rubric is separated into multiple types of goals. So there's procedure requirements. There are actually, for this task, there are only procedure requirements. But in general, there may be different kinds of requirements that are grouped together. And then in each kind of requirement, there's a separation between core goals and extra goals. As I mentioned, the core goals will really get you most of the credit. If you are missing core goals, that's also bad in terms of your grade. The extra goals are only worth that last 5%. And even if you're missing all of them, you can still get a 95 out of 100 by doing all the core goals. So you can read through the details here where it says, okay, this is what the summary of the goal is, or the title of the goal, and then this is a more detailed description of exactly what you need to do to satisfy that. If there's something here that is unclear to you, please ask us a question. And there are multiple mechanisms for doing that, but we would be happy to clarify if there's something that we've written in these rubrics that doesn't make sense or doesn't quite explain exactly what we're asking you to do. For this task, again, it is fairly straightforward. We're going to look at your code and say, did you use this function? If you did, you got it. If you didn't, you didn't. There's no complicated, like you must use it twice kinds of deals going on here. There are some places where you have multiple options and you only have to use one of them, but the requirements are fairly straightforward for this task. So that's it from me. You may see me in more of these videos as we go on to the other problem sets.